Greetings everyone. Today we're going to explore writing parabolas and graphing them in Focus Directrix form, but specifically today they're going to be translated. If you're looking for the introduction video where we're at the origin, please see my previous video. So today, when we are talking about moving the vertex, we're going to have our equation look similar to our ellipses and our other conics in that we're going to add or subtract values from our x and our y. Again, just a refresher, you should have this down in your notes. See my previous video if you don't. We still need to identify, is it the x or the y being squared? We need to identify if the formula has a 4, what's my p-value? I need to divide and write that out. Let's jump right into the example for graphing since we have those basics from before. Everything's written nice and neat. The squared value is isolated. The formula has a 4. Therefore, I would need a factor of -4. Let's identify our pieces. Let's start with the vertex, because that's what we're really primarily changing today. The x value is +3, so I write -3. The y says +4, so I write -4. It's still the opposite signs, so you're still familiar with that set of rules. So let's jot that down. Opens, I'm going to look at opens next. The x is squared, which means it's up or it's down. The p-value is negative. Let me identify that. Sorry, the p-value is -4. So if it's up or down and it's negative, then it opens down. So again, I'm looking at something going down through that vertex, right? Focal width. Focal width. All together, that distance is 16. 16, right? That's the original number. Now, I didn't graph my focus yet, so I can't graph my focal width. So let's jump down to focus. My focus, my p-value is 4. My focus should be 4 down because we already said I open down. So here's what's different today. When I identify that, I'm not going from the origin, right? So I'm at -3, subtract 4 more from my vertex, I'm at -8. Now I can plot that focal width. If it is supposed to be 16 wide, that means 8 in each direction. I'm going to be off by 1. Not a big deal. You're going to be off on a lot of these, off of our 10 by 10 graph. Totally okay. And let's go 8 in the other direction. So I can open that down. I can see how wide that is. Well, 16 is a large number, so having a wide parabola makes sense. Axis of symmetry. If I was to slice this parabola in half, it would go through the x-axis at -3. Directrix. Well, if I went 4 down, I would go 4 up, which means I am actually the x-axis for my directrix. So my directrix is y equals 0. I'm slicing the y-axis at 0. Notice, little pattern here, these are always opposite. One's always x and the other one's y. You can rely on that. Domain and range, forever left, forever right, because we're dealing with our, dare I say, typical parabolas. Range, forever down, and all the way up to -4 bracket. Number 10, we do have another one here, and this is for a reason because this equation is not written correctly. First, we need to rewrite this. We need to isolate the quantity squared, and since nothing's being added, I'm going to just show that by putting +0. You don't have to, but I just understand it better if I write it that way. Now, that -1/28 needs to go to the other side of the equation. Normally I'd say we divide by -1/28, but instead I'm going to multiply by the reciprocal because it's a fraction, so that's just easier. So we have a -28 with the x minus 1. Now I actually don't want the negative 28. You can either erase or rewrite, but we care about the 4. So I can find my p-value. What's 28 divided by 4? 7. Do you see how I got that? So again, this one really exemplifies the fact that we need to isolate the squared value by whatever inverse operation we need to do. We then need to break apart that 4 to figure out our p-value. So my p-value is negative 7. Opens. The y is squared, which means it opens left or right. The p-value is 7. Excuse me, negative 7. Because it's negative, that means it opens left. Does that make sense? And if you need to wait to answer those questions until you figure out some more of the information, totally fine. Vertex, let's get that taken care of. That's always easier. The x says -1, I write +1, and the y is 0. So here is my vertex. Focus, let's find our focus. Our p-value is 7, and we're opening left. That means I go 7 left. 1, 2, 3, 4, 5, 6, 7. That means my focus, exists at -6, 0. Oops, wrong line. -6, 0. Okay, so let's do our directrix then. That means my directrix, I go 7 in the other direction. So I'm at 8, and I slice the x at 8. My axis of symmetry, if I slice my parabola in half, it's going to be y equals 0. Hey, look at this pattern. I know I keep talking about patterns, but if you're a pattern maker like me, the y is 0. Interesting. Check to see if you notice that pattern throughout before you rely on it. Focal width, let's spend time there. 28 is my factor out front. 28, oh my goodness. So if I want a distance of 28, that means from the focus I go 14 in each direction, which would be off the graph by 4 because this is a 10 by 10 graph. So I have a super wide parabola. That makes sense. 28 is a very large value. Now, because you're off the graph, you don't have to be perfect or exact. I'll know by you identifying the focal width if you truly understand. Domain, -infinity to the x value of 1. Domain, range, forever down, forever up. Alrighty, let's jump to the writing section of our foldable. So I'll give you a minute to find example 23 and pause if needed. Now, as with our other conics, writing from a graph tends to be much easier. So this should go pretty quickly. Now, the one thing we can rely on, and the way I like to start these personally, is a quantity squared equals 4 p-value quantity, right? I shouldn't even have put a line in there. So I want to fill this in first. So first thing I notice is my parabola is going up or down. Up or down means the x is squared. Okay, that's what I decided first. Next, I'm going to identify my vertex. I can see that my vertex is at -1, 2, 3, 4, 5, 6. -6, 1, 2, 3, 4. So that means from x, I'm going to add 6. From y, I'm going to -4. Okay. Next, I see I have a distance from the vertex to the directrix and to the focus of 1. 1 is my p-value then. My parabola is opening down, so that means my p-value is -1. Now, as you know from the previous examples, we don't leave the 4 written out. We multiply those, so it should just be a -4 out front. Let's jump to this one, example 24. Now, I added this red line because I believe, possibly if we haven't fixed it yet, you might have an error. Okay, so please go make sure that you fix that. Meaning, how do you know? Well, my distance is 4 from the vertex to the focus, so it should be 4 to the directrix. So the red line's correct on mine. All right, I'm going to do my general setup first. Again, maybe you don't think that way. Maybe you can jump right into everything. Totally fine. I just like to break it up. Next, my parabola is opening up left or right. Left or right means that the y is squared. It's opening to the right, which means my p-value is positive. My vertex is right here. My vertex is at -1, 2. -1, 2. So that means my x is going to have a +1, and my y is going to have a -2. Distance. The distance from my vertex to my focus is 4. So that means 4 is my p-value. And let's tidy this up. Y minus 2 quantity squared equals 16 quantity x plus 1. Now, as we know from our previous conics, from information is just a little bit tougher. So I'm a visual learner. I like to use a graph, use a marker board to figure it out. You guys decide your approach, okay? I see I'm at 4, 2, and 4, 4, 3, and 4, -2. 1, 2, 3, 4, 2, 3. That's my vertex. My focus is at 4, -2. So just a quick little sketch helps too. If that's my focus, that means it's something like this, right? So let's do our general setup. That's how I like to think. It's opening up or down, which means it's my x value that's squared. Don't forget the squared. My vertex is at 4, 3. So the x is going to have subtract 4. The y is going to have subtract 3. The distance from the vertex to the focus is a length of 5. Now I could count that on the graph or acknowledge the distance of the y's. From 3 to -2 is 5. My graph's opening up downwards, so it'd be a -5. So let's tidy this up. Quantity x minus 4 squared equals -20. Y minus 3. Vertex and focus again. All right, I'm going to draw a little sketch again. -1, 7, 2, 7. All right, so I'm dealing with mostly the first and second quadrant. -1, 7 is my vertex. 2, 7 is my focus, which means it looks something like this. All right, let's set it up. My graph is going left to right, so that means the y is squared. My vertex is at -1, 7, so that means x plus 1, y minus 7. The distance from the vertex to the focus, if I acknowledge this distance from -1 to 2 is 3. It's opening to the right, so it's positive. Let's tidy that up. We've got a positive 12 out front. All right, this time we're given the directrix, so it's still going to help me find my distance. I'm going to draw a little sketch here. 2, -5 is my vertex, and my directrix is at x equals 3. Directrix is the sort of, again, it's not an asymptote, but I just think of it that way. I think of it like a border, which means that's what I'm trying to avoid. So my parabola would look something like this. Does that make sense? You have to understand what that directrix looks like on a graph. Let's set it up. Quantity squared equals 4 p-value quantity. It's opening up left or right, which means it's y squared. My vertex, I'm going to have a -2 and a +5. The distance from my vertex to my directrix is 1. The x values have a distance of 1. It's opening up to the left, which means -1. Let's tidy that up. If I multiply that, I've got a -4. So whether I give you the vertex or the directrix, whether I give you the focus or the directrix, you'll find your p-value. Now on this one, what if I give you the focus and the directrix. Now we don't know our vertex. We have to find it. Dealing with mostly the second and third quadrant here. If I'm at -9, 8 for my focus, and my directrix slices the y-axis at y equals -6. So let's talk about this distance from here to here. From a y value of 8 to a y value of -6, that's a distance of 14. Well, my vertex should be right in the middle, which means a unit of 7 units away. If I go 7 units from both of those, I would exist at -9, 1. You see how I got that? If I look, I just split up those distances. If I knew it was 14, now I just proved it's 7 and 7. See how that happened? Let's set up our equation. Quantity squared equals 4p quantity. Alrighty. Based on the information I have and where my vertex and focus are, my parabola would look like this, meaning it's opening up or down, so it's a regular x value that's squared. Oops, I don't know why I wrote x in the other one. My apologies. It should be a y over here. My vertex is -9, 1, so that means I'm going to add 9 to the x, subtract 1 from the y. And I just wrote in green here, the distance between is 7. It's opening up upwards, so it's a +7. Let's tidy it up. X plus 9 squared equals 28, y minus 1. Here's an extra example if you feel like you need it. I'm not gonna do everything for this example, but I just want to stress again that we need to write this equation accordingly, meaning I need to isolate the value squared. So instead of dividing by -1/4, I'm going to times by -4, the reciprocal. It includes the sign. So my function, I'm actually going to flip the whole thing around, would be y plus 2 squared equals a -4 quantity x plus 0. So just really stressing you need to isolate the squared piece. A quick reminder, I am going to do this example because we haven't had one like this yet. Let's start with our vertex because that's pretty easy to see. We've got 2, -2. P-value. Or no, let's do opens actually. Opens. The x is squared, so it's up or down. My factor out front's negative, so it's going to open downwards. Now normally I say, hey, let's rewrite this with a 4 out front. But what can I multiply a 1 by? Technically there's a 1 here. What can I multiply 4 by to get a 1? Right? If I divide 1 by 4, it'd be 1/4. You see how I got that? 4 times 1/4 is 1. Positive times negative is negative. So my p-value, believe it or not, is -1/4. So from the vertex, I'm going to go down a 4th. From the vertex, I'm going to go up a 4th. Which means my directrix is going to be y equals, well, let's see, what's -2 plus a 4th, -1 3/4? Or really we should say -1.75, or y equals negative, oh gosh. I'm going to write this a few ways. Sorry, brain fart. Oh my gosh. -1 3/4, or y equals -7/4. Okay. I'm kind of open to how you write that directrix because all of those are good forms of a line. But the fact that we barely went away from the vertex is okay, which means let's talk about the focal width. The focal width, my original number was 1. My focal width is 1. If I want a focal width of 1, that means I go half in each direction from my focus, which means tiny, tiny parabola. Very, very, very skinny. So my focus, oops, I didn't write that out yet. My focus has the same x value as my vertex, 2, and negative 2 1/4. I'm open to how you write that. So very, very skinny. Domain, forever, forever. Range, bottom to top. Okay. Oops, sorry, that should be a negative 2 though. Negative 2. So I just wanted to throw this example out there to remind you that you can have very small numbers. You might have a p-value that's a fraction. That's okay. Alrighty, thanks for bearing with me in this video. I know some of these get to be a lot, but conics is so involved and we just want to make sure to cover all our bases in these videos. So as always, check out Google Classroom to see what our task is today. Make sure to use Desmos as a resource. Let me know if you have any questions, and until next time, have a good one.